Okay, in this video lesson, we'll look at solving a system of equations or finding the solution algebraically. Specifically, we'll focus in on substitution. And so, first to understand, when do you even use substitution? Substitution is used when at least one of the equations in your system has a variable isolated. Here we have a system, there's a different system, and a third example. In our first system, we can see there is a variable isolated. Actually, both of them have a variable isolated. While the second one, there's only one equation that has a variable isolated, and in the third, it also has a variable isolated. So all three of these scenarios, substitution would be the most common method used. So we'll look at the first one. The strategy I suggest is circle a variable that's isolated, then box what's on the other side. And essentially what this says is whatever the circle is, the box is the exact same thing because of the equal sign. And so then you look at the second equation. It also has that same isolated variable. So this says wherever I see that circle, I can put this box. So we'll be substituting. So I set myself up. There's the equation I'm about to substitute. So in place of the y, the circle, I'll be putting the box. And what I've actually done is gone from one equation that has two separate variables to a single equation that now only has one variable. And so I'll just go through the motions of solving this equation. I'm going to remove this linear term from one side, constant term from the other. So I'll add 5x on both sides, add 4 on both sides. The 4's cancel and the 5x's cancel, leaving me with 12x on one side, 24 on the other. Divide both sides by 12, x equals 2. So now I have just the x coordinate of my ultimate solution. As a reminder, the goal when solving a system of equations, essentially that means you're essentially trying to find a point where two lines intersect. So here to find that point, we need both the x coordinate and the y coordinate. My recommendation is this. If you use the second one, in this case, to find one variable, we'll use the other equation to find the other missing variable. So we solved using the second equation, so we'll use the first equation to find the other coordinate. So wherever I see an x, I'll put a 2. So 7 times 2, 14. 14 minus 4 is 10. So now we have both the x coordinate and the y coordinate. Our solution is 2, 10. Again, which essentially says this is a line, this is another line. These two lines intersect at the point 2, 10. So we'll do another one. The strategy again is first start by circling an isolated variable. Then box the other side. So this sets us up, says wherever I see the circle, I can put the box. We circled the y in the first one, the second one, there's the same y, which means in place of that y, I can put what's in the box. So I set myself up. This is the equation we're about to substitute. So in place of the y, let's go back just to show again. In place of the y, we'll put the 2x minus 5. So there's the 2x minus 5, right behind the 7. So we'll begin to solve by the traditional methods. I'll first distribute the 7 to the 2x and the 7 to the negative 5. Simplifying that gives me the 14x minus 35 after I distribute. Combine my like terms, 18x minus 35 equals 19. Solve by adding 35 on both sides. The 35's cancel. 18x on the left, 54 on the right. Divide both sides by 18. X equals 3. So just like the first one, this is only half of our answer. This is now the x coordinate. Time to find the y coordinate. So just like before, the recommendation is I use the second equation here. When finding one variable, I'll use the other equation. And it's already set up for us to find what y equals. So I'll substitute 3 in place of x. 2 times 3, simplify. 2 times 3 is 6. 6 minus 5, y equals 1. So my solution to this system would be 3, 1. One more example. Just like the two previous, the strategy is circle the isolated variable. So in this case, the isolated variable just happens to be the b. The recommendation, box the other side. So it says, wherever I see the circle, the b, I can substitute the box, 4a minus 13. The other equation, there's the b. So in place of the b, we're going to put the 4a minus 17. So because I'm going to substitute into this first equation, I'll first show there's the first equation. So in place of this b, we'll be putting the box, 4a minus 1. So there's the 4a minus 17. So just like the previous problem, we'll apply the distributive property. I'll distribute this number here. Now be careful, that's not a 3, that's a negative 3 that will be distributed. So negative 3 to the 4a and negative 3 to the negative 17. Well, negative 3 times 4a is my negative 12a, and negative 3 times negative 17 is positive 21. So we'll combine like terms. The 2a minus the 12a gives us a negative 10a plus the 51 equals 1. We'll remove the 51 by subtracting 51 on both sides. 51's cancel, leaving me with negative 10a on the left, negative 50 on the right. Divide both sides by negative 10, a will equal 5. So that's the first coordinate of our ordered pair. So like all the others, here we use the first equation in finding the first variable, so I'll use the second equation, which is set up for us to find the other missing coordinate. So b equals 4a minus 17. So in place of the a, we'll put the 5. 4 times 5 is 20. 20 minus 17 is 3. So we now have the ordered pair. And again, because it's an ordered pair, it's in a particular order. In this case, alphabetical order. So we'll put the a first and the b second. So 5, 3. So hopefully this gives you a better understanding how to apply substitution when solving a system of equations.